Hello, welcome back to Statistics and Mathematics YouTube channel. So we are going to tackle what is termed as a discrete bivariate distributions. So for definition, a joint probability mass function. How are we going to describe or discuss or define the joint probability mass function under the discrete bivariate distributions? So in the slide we said let x and y be a discrete random variables. So if this x and y is being pulled together in what? A function, as you can see here, f of x comma what? Y, right? It means that our x is a random variable and our y is a random variable, and they have been put together to form what? A function, right? This function is equal to what? The probability of both x and what? Y. When these functions are being able to put together, right, then that is termed as what? A joint probability mass what? Function, right? So for this function to be verified, or for this function to be able to qualify to become a joint probability mass function, there are some necessary and sufficient conditions that this joint probability mass function of both x and y must be what? Must be able to what? Achieve, right? So for one, you see, before we discuss this one, I want us to remind ourselves on the univariate cases where let's assume we are having just one random variable x, right? Just one random variable x, and then for it to become a discrete random variable, first we say that f of x must be what? Greater than or equal to what? 0, and then summation of what? F of x must be equal to what? 1. That is under what? The discrete case. So when we come to the continuous case, it's the same thing, right? The joint function of what? X and y must also be what? Greater than 0. And then when we sum on both x, right? When we sum on both x and y, right, of that function, when we sum, the summation must be equal to what? 1, right? So this is the necessary and the condition for two random variable to become a joint probability mass what? Function, right? So once this one is being achieved, right, that is qualified to become a joint probability what? Mass function. So let's solve some examples to better our understanding on this concept. So here the first example says the table shows the joint probability mass function of x and y. So this is the table, and you see we are having joint, that is f of x comma y. When we come to the top here, we are seeing y here. When we come down here, we are seeing what? X. And under the y, we are having 3 observations, that is 0, 1, 2. And under the x, we are having 2 observations, that is 0, 1. Right? So that means that when we pair both x and then y, then we are going to get what? The probabilities that we can find what? Here. Right? Yes. So there is some follow-up question that they want us to use this particular table to calculate for. Right? So A, it says that we should find the probability that our x is equal to 0 and y is equal to 0. So you are just going to come to the table and just locate where our x is equal to 0. We are just locating that our x is equal to 0 is here, right? And then y is equal to 1. We are just locating that our y is equal to y here. So where are the 0 and then 1 at x and y meet, right? They meet as what? 0.4. So in this case, since our x is equal to 0 and our y is equal to 1 and they are meeting at 0.4, then the probability here is equal to what? 0.4, right? So we can see clearly that the probability here is equal to what? 0.4, right? And the second question says that we should find probability that our x is equal to 1 and y is equal to 2. So we just come to our x section. Our x is equal to 1 is here, and we come to the y section. Our y is equal to 2 is also here. Where are they meeting? They are meeting at what? 0, right? So we are just going to trace, and we are going to trace this one here. They are meeting at 0. So that probability is equal to what? 0. So when we come here, we are getting what? 0 as our result, okay? And the third question says that probability that our x plus y must be greater than 1, right? That means that if I ask x plus y is supposed to be greater than 1. So let's come here. 0 plus 0 is giving us what? 0, of which is not greater than 1. So we are not going to take 0 and 0 pair, right? 0 plus 1 is equal to 1, of which is not greater than 1 here, right? So we are not going to take 0 and 1 what pair. 0 plus 2 is equal to 2. So we are going to take that pair, right? So let's write that one here. We are getting probability that our x is equal to 0 and then y is equal to 2, right? We are going to add it to some probabilities, right? Since when we add our 2 plus 0 is greater than 1. Okay, so let's come here. 1 plus 0 is not greater than 1, so you are going to leave it. 1 plus 1 is 2. Okay, so probability that our x is equal to 1 and then y is equal to 1 is what? 2 is greater than 1, so we are going to add it. And we are going to also 1 plus 2, which is 0. Of it, that one 2 is greater than 1, so here we are going to get probability plus probability that our x is equal to 1 comma y is equal to what? 2, right? So here, what are the probability? What are the probability that our x is equal to 0 and y is equal to 2, right? The probability is 0.1, right? So you are going to get 0.1 plus probability of what? 0.2, 0.2 plus 0, of which you are getting what? 0.13. So here our final answer is what? 0.13. Okay, yes. And then let's continue. It said probability that our x plus y is equal to 1. So in this case, we are saying that when we add x plus y, surely we have to get strictly 1. If it is more than 1, we are not going to consider it, right? So 0 plus 0 is not equal to 1, so we are not going to consider. 0 plus 1 is equal to 1, so we are going to consider 0.4, right? So let's write it there, 0.4. Okay, we are going to add it to something, so plus. And then when we consider 0 plus 2 is more than 1, 1 plus 0 is surely going to give us 1, so we are going to add 0.2 to it, plus 0.2. And then 1 plus 1 is more than 1. 1 plus 2 is more than 1, so our final answer here will give us what? 0.16. Okay, we are getting 0.6. So here when you come here, it's equal to what? 0.6. Yes, 0.6 will be our final answer for that one. And then this one too, I'll give it to you as an assignment, please. The probability that our x plus y is equal to 2. Can you do it and then leave your answer at the comment section below for me? Okay, thank you, and I'll respond to it if you are right or wrong. Yes, thank you. So let's continue solving it. Okay, yes, so these are the solutions that we were able to find. Okay, yes, so let's tackle the marginal probability mass function, right? So in some instances, we are going to have our joint probability mass function, all right, and then all the conditions that we are to check for a function to become a joint probability mass function, all of them will be what? Achieved. But in some questions, we will be asked to calculate for the PML for only x, right? For instance, we have this joint probability mass function f of x comma y, and then we asked to find for only x, right? F of x, right? In more or less, we have been asked to calculate for the marginal of what? X, right? We can also be asked to calculate for marginal of what? Y. So when it comes in that way, in a discrete case, how are we going to work on that? That is what we are going to discuss under the marginal probability mass what? Function. So when we come here, we are having if in case the probability mass function is given to us, and then it is the random variables are discrete, and then we have been asked to calculate for the marginal of x. All that we are going to do is to sum on all y, right? We summing on all y, it means that we are removing the component of y from the function for us to really get only the component of what? X. So that means that in this case, our x is surely going to be fixed, where our y is going to vary, because we are going to get different values for what? Y, and we are going to remove the y component from the function to get a function only in terms of what? X. So what if we are also asked to calculate for the probability mass if you are asked to calculate for the probability mass function, the marginal probability mass function for y, only y, for that one we are going to sum on what? X, of which our y is going to be constant and our x is going to what? Vary. So our x going to vary means that we are going to get different value observation for x, and then that different observation for x, when we put it inside the function, we are going to remove the component of what? X outside from the function, and then we are going to get a function only in terms of what? Y. So let's solve some examples under this one for us to also understand a lot. Okay, yes, so let's tackle this question. Okay, yes, so he said determine the value of the constant c that makes the function f of y, which is equal to c bracket open 2x plus 3y, a joint probability mass function over the 5 points with x is equal to 0, 1, 2, and then y is equal to 0 and 1. Yes, so all that we have to find is to just calculate for the constant c. And then when we just started the bivariate 2, we just learned that when we sum on both xi and then yi, right, we are surely going to get 1, right? And since there is a constant here, then it means that when we sum on both x and then y, and then you just equate it to 1, we can find what our constant what c, as you can see here. So that is what we are going to do, right? And then we know that for this case, we can either sum x first or sum y first. It's not always static that always sum on x before you sum on y. For this case, we just choose to sum on x first, right? And then we just learn that our x, we are summing from 0 to 2. So here when we come here, we are going to start from 0 and then we are going to end at 2. And for y, we are summing from 0 and 1. So we are starting from 0 and then we are ending at 1. So first, all that we are going to do is to take the x observation and then just put them into what? The joint function, as you can see here, right? So first one, we are dealing with the x, right? And then for the x, you have observation of x to be 0, 1, and then 2. So when I take this function, everywhere I see, I'm just going to do for the x first, x equal to 0 first. So anywhere I see x, I'm going to put 0. So here I'm going to get 2 times 0, of which I will get 0 here, plus 3y, right? Plus, I'm going to take s is equal to 1. So when I take s is equal to, I'm going to substitute that one here. So I'm going to get 2 bracket open, 2 times 1. Of which I'm going to get 2 here, plus 3y, right? And then I'll take s is equal to 2. When I take s is equal to 2, I'm going to get 2 times 2, of which I'm going to get 4 here, plus 3y, right? So it means that I've already summed on what? X, right? Yes. So once I sum on s, I'm just going to add it to this one. So here I'm going to get 6 plus 9y. 6 plus 9y. Once I add everything here, right? So all that we are left here is to also sum on what? Y. So anywhere we see y, we are going to substitute y is equal to 0 and y is equal to 1. So here c bracket open, 6 plus 9 times 0 plus 6 plus 9 times 1, of which we are going to get c bracket open of what? 21. And then we get our c to what? 1 over 21. So once we get our c to 1 over 21, we just come and just write the joint probability mass function appropriately, right? Like this one, and then that will represent the joint function since we now have our c. So once you have the c, we can also solve the follow-up question. So the follow-up question is telling us to find the marginal probability density for x and then y, right? Yes. So for the x and y, I told you that for marginal probability for x, right? Marginal probability for x, we are just going to sum, right, on y. We are just going to sum on y. So here we're going to move from y is equal to 0 to 1. And then for marginal of y, we are going to sum on, for marginal of y, we're going to sum on x, moving from 0 to 2 of fxy, right? So that is what we are going to do. So I have the solution here. Let's go to that so that we can finish faster. So here we are summing on y, right? So we are going to have 1 over 21 bracket open 2s plus 3 times what? 0. Since anywhere we see for the first instance, I'm going to select for y is equal to 0. So anywhere we see y, I put 0 there. That's the reason here we are getting 0. And then we do for the next one. Anywhere we see y, we are going to substitute 1 there, right? That is why we have 3 times 1 here. So once we add the 2, we are going to get 1 over 24 plus 4x plus what? 3. Where, so this the marginal of what? X, where our x here will be 0, 1, and what? 2. That's the marginal of what? X that we are finding here. So for the marginal of y, right? So for marginal of y, we are also going to sum on x, where we are going to consider x is equal to 0, x is equal to 1, and s is equal to 2. So when s is equal to 0, this is what we are going to have. When x is equal to 1, this is what we are going to have. And when s is equal to 2, this is what we are going to have. Once we add everything together, we are going to get 1 over 21 bracket open 6 plus 9y, where our y is equal to 0 and then what? 1, right? Yes. So that is how we can calculate for what? Our marginal of what? X, and then our marginal for what? Y. Yes. So for the c, right? So for the c, it said present the joint probability mass function in parts A, in a tabular form, right? So that is what they want us to do. You see, this will be our join, right? And then this place will be for x, right? The row one will be for x, and the column one will be for what? Y, right? So here we are having our x to be 0, 1, and 2, and we have now our y to be 0, 1, right? So already we have the PDF, right? And then we know the PDF is 1/21 times 2x plus 3y, right? So we are just going to take, if our x is equal to 0 and y is equal to 0, and just substitute it here, right? When our x is equal to 0 and y is equal to 0, we are going to get our answer to be 0. What if our x is equal to 0 and then y is equal to 1, right? When we come here, we are going to get 1/21 of 2 bracket open 0 plus what? 3 times 1, of which you are going to get 3/21. That's the reason I had 3/21 here, right? So what if we have x equal to 1 and then x equal to 0, right? So x equal to 1, we are going to have that plus 0, right? And then you are going to get 2/21. So that's the reason why we had this one here. So you are going to keep on just selecting the observation to to complete what? The table, right? So that is what we have here. And then in some cases too, the table will be given to you, and then you will be asked to find the probability mass function for both x and y. When it is given to you, if our s component is at the row section and the y component is at the column section, for us to get the marginal of x, we are just going to add the probabilities at what? The row total to get the marginal probability for y, right? And then add the probabilities at the column section to get the marginal probability of what? Sorry, let me come again. If we add the probabilities at the row section, we are going to get the marginal of what? X. And if you add the probabilities at the column section, we are going to get marginal of what? Y. So that is what we have done here. We add the probabilities here, we add them here. So if we want the marginal of what? X, we are getting this answer for you, right? Yes. And then if you want the marginal of y2, we are getting this answer for you. So this is Statistics and Mathematics YouTube channel. If you haven't subscribed, kindly subscribe, like, and share, so that this video will also get to your friends for them to also benefit from it. Thank you. Bye. Have a lovely day.